Hello, good afternoon, everyone. Can the people online hear me? Awesome. So I just confirmed people online can hear me. So if you're joining us online, welcome, welcome. My name is Toby. I'm going to be your anchor for today. So we're just going to we'll be waiting a couple more minutes. So whilst we wait, just drop your name and where you're joining from. So we just know that there's interaction going on in the chat room. So your name, where you're joining from, and the people like on site too as well. So you can just introduce yourself to someone. Let's network because that's what we do here at data scientist network. Emphasis on the network. Yeah. Hello, good morning, good afternoon, good evening from wherever you're joining us from. My name is Toby and I'm going to be your anchor for today. So we're going to be starting in the next 1 minute. Before then, please make sure you introduce yourself to someone. Drop your name in the chat box where you're joining from. And let some interaction go on.
Huh. How's the weather today in Shenzhen?
Currently, in Shenzhen, China, it's 27 degrees Celsius with cloudy skies.
Ah, alright. Ask Uber for a ride.
There is an Uber X 4 minutes away from your Uber home address. Should I order it?
Yes, please. Oh. Turn off my room, please.
Okay.
Taxi!
你去哪里？
Where are you going?
Please take me to Hilton Hotel.
请带我去希尔顿酒店。
好，没问题。
No problem.
What's the function of this motherboard?
这块模板的功能是什么？
哦，这是我们方案的演示吧。
It's our solution demo board.
Hello.
Do you have a cappuccino, medium size, without sugar?
Do you have a hot cappuccino medium size with no sugar?
你有热卡布奇诺咖啡吗？中杯，不需要糖。
Today was my first day in Shenzhen, China. Such an amazing city. We enjoy the food and the people.
Good evening, from wherever you're joining us from. Please let me just confirm if you can see my screen. Okay, awesome. So before we get into it, I'd like to say welcome one more time. My name is Toby. I lead partnerships and collaborations at Data Sciences Network. And I just like everyone here to just put your hands together for yourself, because thank you so much for coming. I understand it's a little tedious moving around in this time. So over the next couple of minutes, I'll be introducing you to who we are at BSF. So now, if you knew us before, our commitment was to raise 1 million AI talents in 10 years. That was just it. Oh, we want to raise 1 million AI talents in 10 years. That was it. But our commitment has evolved. Now, above 1 million AI talents, we're also trying to develop solutions for 2 billion people in emerging markets. So I think that deserves another round of applause. It's larger than just us. It's larger than who we want. It's more about who we want to impact. Now, because we want to deliver on 2 billion people, our focus is now on 3 different things. We are going to be using our community for learning and research today. Product development for social impact and partnerships for solution delivery. So essentially, we're working with 3 things: community, products, and partnerships. That's what we are working on. So if anybody asks you, "Oh, what is the mandate of Data Scientist Network?" It is raising 2 billion people. How are we going to raise it? 2 billion, we're developing solutions for 2 billion people in emerging markets, and how are we going to do it through community products and partnerships. So now our evolution over the years, we went from a learning community to building AI solutions for national development. Currently, we actually have a national dashboard for financial inclusion in partnership with NVIDIA. We'll go into that later on. So we see we're the largest learning community in Africa. It seems larger than life. So how do we verify this? We won the Master Impact Award at Deep Learning in Indaba 2019. So for those of us who are not yet tech pros, we don't know too much about the tech community. So Deep Learning in Indaba is a cross-continental, let's say, the cross-continental institution. They're the ones that connect people, anything data science, anything artificial intelligence across Africa. That's what they do. So they connect people. That's the community that they built. So we won the Master Impact Award in 2019. We also won the best academic poster at the 2021 Global Challenges in Economics and Computation, and which we think is funny because we're not actually an academic institution. But yes, we won that. So now we're seeing our prowess in research paper writing. The expert award was for $500,000. It was supposed to be develop a solution to combat the COVID-19 and all the problems that came with it. So we developed the solution. We're actually the only African finalist. So please put your hands together one more time for DSM. So you've seen our impact in research. You've seen that more than just research, we actually do solutions as well. So DSM's work has been presented across the globe. So we're at AAAI last year. This was our founder speaking, giving a keynote speech at AAAI conference. AAAI is where the crème de la crème, the people who define the next stride in artificial intelligence gather. So all the professors, all the companies, they come together. We have conferences to decide the next steps. So we're there. Now, DSM released the first artificial intelligence and Python for elementary students and beginners in Africa. So if you want, I think my colleagues will be dropping the link in the chat. That's if you're online. So if you want to get a copy of this book, if you also want a hard copy, you can speak to people and the reception. That's for the people on site. This is a breakdown of AI like you've never seen it before. It was actually, this edition was actually supported by Softcore. They wanted to give to the mission, and this was their gifts. So now you are in our very special AI research lab. So this is the training room. We also have 2 floors above. We have the robotics lab. We have AI startup incubation lab, and yes, that's pretty much it. So after solutions and research, this is our stride, this is our newest stride in products. So IRCAI, under the auspices of UNESCO, they gave 2 of our products, the top 100 AI products in 2021. So please, one more time, a round of applause for DSM. So our Ed10 AI adaptive learning engine. I don't know if all of you know about it, but we had a program, Masterclass Foundation. Created this for that. This was Learn at Home. And Christian Rights, those were the 2 products that were given that award. So now, beyond DSN as a foundation, this new year, moving forward, we're going to be partnering people across these 6 industries to develop and to deliver the solution that we're talking about. Because 2 billion people is no small number. So we're going to be partnering people in career tech, fintech, retail tech, edtech, platform tech, and health tech. So now these 6 industries, the reason we're doing it is because we want to have an AI vertical partnership. So what that means is across the board, from end to end, the supply chain. So it doesn't really matter what you're doing, as long as you have the ability to power this model, we're going to be working with you, or we have the potential to work with you. This is our last cohort of AI incubation. So now, beyond the research lab that is here, we also have a new institution just to support startups, because we know that, more especially in this side of the world, it's harder to, let's say, get a good start on things like this. So this is our last cohort. If you want to learn more about the AI incubation, you have an idea, you want to develop a solution, you think that you fit into this category, so please just head out to datascience.nigeria.org/AI to put down your name to register. So our community of practice, this is huge, because I feel like we fall under this one way or the other. So we have a community of learners, of professionals, different kinds of people. So we already have events for the whole year structured out for everyone. So please make sure you head on to datasciencenigeria.org/GSM community calendar. So you see this full list, you see where you can register, where you fall into, and so on and so forth. Now, this is supported by our advisory board. This advisory board is led by Dr. Uyi Stewart, who is the Senior Director of Data Science at Seattle Genetics. So this board, they are the people that actually power mandates. These are the people that said that, across the world, I would like to be a part of this. So let's put our hands together for this new advisory board. I'm sure you know some places here, but these are the people that are powering the mandate. So thank you so much for listening. I'm going to be inviting Anu, who is our performance and delivery lead, for just a welcome address, just to welcome you to the essence. So please let's put our hands together for Anu as he comes forward.
Thank you, Tolu. Hi, so good morning, everyone, once again. Good morning. My name is Anu. So I need to do the one, so scientist. Thank you all. Nice to connect with you this day. So this is DSN. I think we have done justice majorly to what we have and who behind DSN. I'll just say a few things about this session and where we had to hold this session. And so I think I'll actually begin initially from our mandate, which is to raise 1 million AI talents, right? Which is now evolved into 2 million mandates like that. That's what we're referring to now, right? So DSN is a very passionate organization who has seen itself as a channel to building an healthy talent, building solutions and raising goals. We believe that Africa is where we have the next set of the revolution that's going to happen, right? And we want to be better positioned to have and help our talents to developing skills that are necessary for the future of work. And like our founder always say, right? What you visualize or what you're able to see, you understand better, right? So that's why this class is very, very important. I mean, we have actually seen it as an opportunity to not just only help the community, a community of learners and practice at large, but also to at least make it do. Please can we, that's our executive director, so she leads the entire process. So okay, so thank you very much. Apologies for the break. So, like I said, DSN is all out to help. Now, not just to help, to equip our young talents that will believe that they need the necessary skills to be able to compete with global students, global persons. I mean, a child in US as much as the child in Nigeria should be able to stand toe to toe with someone in the United States. When you are sure, you are very, very sure that you have the skill that is necessary. And that's why we're bringing one of those things that we have in store, which is the data visualization. So data visualization class is meant to help to build your skills in one of the visualization tools which we have adopted and we're running a special masterclass for. So sit down. We have a current class that is running, I mean, series of classes that are running for quite a while. But we have in our midst an expert all the way from the United States of America. I think we want to appreciate her. So I'm taking our time to come and speak to her for the next 1 hour. Let's be all attentive for our participants that are online. We appreciate you being here. This is DSN, and we are very hopeful that at the end of this session you have something to go back with. So thank you very much. I think before I leave, I'll have to quickly run through a brief introduction of our speaker, then we can move to the session. So Kate is currently the head of global DevRel and emerging areas at NVIDIA. Please do not stop. Can we do appreciating her? So she's in this role, Kate oversees startups ecosystem, strategic partnerships, communities and developer relations for global markets. So excluding US, EU, and China. So she leads social innovation and emerging applied AI use cases. Actually works closely with partners and influencers to create disruptive AI applications and aims to build a truly global and inclusive AI community. So prior to NVIDIA, it spent close to a decade at various semiconductor companies, holding developer product, ecosystem, and business positions in AI, computer vision, and IoT. And the mission to democratize AI and train 1 million African developers. She regularly advises international organizations, governments on the power of AI to impact communities and drive social impact. um, a DAI mentorship advocate, sorry, ADI and high mentorship advocate. She often mentors teens on career development and startups on tech and business. She has won multiple accolades throughout her career, being named Business Insider Top 100 Transformers 2020. This can we appreciate her. VentureBeat Women in AI Rising Star in 2020, the CES Best of Innovation Award, and the China AI Industrial Innovation Alliance Most Remarkable Product Award. This TSN, let's people welcome Kate Kallot as she takes the session on the Spectrum Masterclass. Okay, so apologies before Kate, so before Kate takes the class, please I would advise if we can move to the front, please. Let's try and view the front space so that it's easier to quickly communicate and we can have everyone capture, please. On the let's connect to the Zoom link. First step.
Need to be made to present. Hi everyone. Hello. Can you hear me well? I hope you're all doing well. Thank you for coming today. I'm really excited to be here with you. Can you hear me okay? Do I need to? Okay, so you can. Okay, great. I'm Kallot, and like I said, I'm the head of global business relations and emerging areas at NVIDIA. I am originally from Central African Republic. Not far from here, but a small country from Francophone Africa. But I grew up in France and Paris mostly, and then I got into tech a little bit weird. I don't know how to start this way into tech. I actually was not really aware of technology growing up, and I started my studies. I started university by studying law and political sciences because I wanted to become a lawyer at the beginning. Then 2 years later, I decided to drop out, and I joined a communication school because I thought I wanted to become a journalist. After a year of journalism, I went to study in Japan. I was fortunate enough to be able to get a sort of scholarship and go study in Tokyo. And that's when I discovered technology. One of my professors at the time used to be director of marketing at Sony. And he used to work on the Walkman. Does anyone remember what the Walkman was? Yeah, exactly. They have this ad on TV with chimpanzees, and everybody knew this ad, right? And he was talking about the movement, and when he was telling us about everything he was doing at 30, I was just amazed, and I was like, oh my god, this is exactly what I want to do. So I had a little discovery internship at Google, and then when I came back to France, I applied for an internship at Intel Corporation, the company in Paris. So I got the internship, I started as an intern there, and then I started to move around with Intel and join different positions, and all of a sudden I started to work in IoT. I was a business development manager in IoT and new technology in Europe, and I got promoted both from Europe to the US and became a global manager. The funny story is my division at Intel was a very, very new division. Very small as well compared to the large company. I mean, it's a company of 100,000 people doing $70 billion revenue per year. Our business unit was really, really small. And the business unit got shut down. It got shut down, and I have two options. The first one was I take I try to find another job in the company. The second one was I just go out to Europe and start over. So I had two options in the company. One was IoT, and the second one was becoming a product manager for a deep learning development piece. And it's not really nothing about AI, it's just things that I have heard. Because bear in mind it was 2015, 2016, so AI was just becoming a new thing. And Intel had just acquired a company, a startup called Omniverse. That's the moment where a lot of big tech companies started to acquire hardware startups, AI hardware startups, and Intel had acquired a startup called Omniverse, which was focused on computer vision, deep learning at the very, very edge, like at the endpoint, on very low power processing unit. They had a chip called a vision processing unit, and they wanted to democratize AI. They wanted to make AI accessible to everyone. So they built what we call the Movigus Neural Compute Stick. Have you heard about this? It's an AI development kit in a USB form factor. This device, we launched this device. I became a product manager for this device. And when I decided to take the job, they told me, congratulations, you have 3 months to learn everything about deep learning, AI, computer vision, because we're launching in 3 months. So I had to go back and understand how to use the product. For someone who had never coded in her life, that was a big learning step. I had to sit down with my engineers and move my head from what is IoT to what is AI, deep learning, computer vision, and the convergence of all of it. So it was a very humbling and hard moment, but it was the beginning of something, because that's how I actually got into AI. We launched the product building 3,000 units, and we were sold out in less than 3 days. And at the time, I remember when we launched at the conference, NVIDIA was also at the conference, my current company, and NVIDIA was a little bit jealous. We had a queue of people waiting just to get their hands on the product. The product was all over the news. So I called this product, thank God, my lucky charm, because that's what got me into AI, and that's the reason why I'm here today. After that, I started from product manager for that product, and then I ended up managing the whole product line, except the engineering team. So I was managing the product managers, the product marketing, the developers, developer relations, business, ecosystem development. And end of 2018, beginning of 2019, I decided it was time for me to move on from Intel. So I joined a company called ARM. Have you heard of ARM? There is a stats that says that 97% of the population in the world has touched one ARM device, at least, because ARM powers most of the mobile phones in the world, whether it's feature phones or smartphones or smart feature phones. 98% of these mobiles or 99% of these mobiles are powered by an ARM CPU. ARM is also a big business in IoT, shipping 10 billion of ARM-based chips every year, and recently got into the MacBooks, the new MacBook that has been launched last year. So I joined ARM as director of ecosystem, AI ecosystem and developer relations, leading teams globally in China, in US, in Europe, and a year after joining ARM, I realized that there was a lack of representation from African developers on the global scene. So I started to look into what can we do as technology companies to make sure that we don't forget anyone when we build technology. One, we provide access to everyone, the same access to everyone to technology and technology tools, but also we give developers a platform for them to showcase their technology, because sometimes solutions that are being built here in Nigeria could as well be used in the US or Europe. The challenges that we're solving here in Africa could be replicated anywhere else in the world. That's when I decided to switch a little bit my career and starting to focus on emerging markets. And that's when NVIDIA came to me and said, hey, we really want you to come on board, what do you want to do? So I told them emerging markets. I joined NVIDIA as head of emerging areas, and last year my job expanded to emerging markets, so Latin America, Africa, and Middle East, to global markets, everywhere except EU, US, and China. With this position, I have a team that's spread globally. I have one person in Ghana. I'm hoping to increase the number of people I have on the ground here in Africa. But one of the things we've launched was the Emerging Chapters program. And the Emerging Chapters program is designed for communities like the Data Scientist Network. What we wanted to do is make it easy for communities and developers within those communities to access our tools and our technology. So we've been working with DSN for quite a while, and it has been a great partnership so far. We've hosted quite a bit of educational series, mostly online, but I'm really, really pleased and fortunate to be here with you today and be able to host this masterclass physically for the first time. And I'll be in Lagos for a while, so I can come back anytime. So today we're going to talk about data visualization best practices. We have a packed agenda. We have a packed agenda, so I'm going to try to move quickly and then open the floor for discussion, questions. If you have anything you want to ask, feel free to raise your hand and we can have a discussion on it. But we're going to cover introductions to NVIDIA, accelerated data science with NVIDIA Rapids, or EGX platform, but also we're going to talk about something that's very exciting right now, which is the Metaverse, and how we're building the Metaverse and what are the best practices like digital twins. So who has heard of NVIDIA? And who can tell me what is NVIDIA? What NVIDIA does? Yes, so we started originally as a computer graphics company. NVIDIA was created in 1993 by Jensen Huang, who is still the CEO today. So our founder is still CEO. It's been almost 30 years. And at the core of our business, our first technology is around computer graphics and simulation. In 1999, NVIDIA actually invented the GPU, the graphics processing units. So we're the original inventors of the GPU, and researchers started to use GPUs for a wide range of applications. It was the moment where the movement called GPU started. And this movement is general purpose GPU computing. But at the time, GPU required the use of graphic programming languages, which were not widely used, like OpenCL, to program those GPUs. When NVIDIA realized the potential of GPU performance for the scientific communities, they went back, modified the GPUs, opened it, and made it fully programmable. And they added support for widely spread languages, high-level languages like C, C++, Python, etc. In 2006, NVIDIA invented CUDA. CUDA is a programming model that runs on most NVIDIA GPUs today. And as the convergence of AI and innovation came into practice, starting in 2009, GPU chips started to be used in AI, widely in AI. And then this history, 2012, 2015, AI started accelerating, and today we're one of the top, if not the top AI company in the world. So I'm going to play you a little video that summarizes quite well what NVIDIA is. So that's what NVIDIA is. Of the And still some echo. And where was I? It's integrated with all the popular industry tools and workflows. So NVIDIA AI has about 150 SDK, which is huge. But each SDK has a specific function. So the ones you see on the screen, GeForce is for gaming, Omniverse is for simulation and building things like the Metaverse. Quantum is for quantum computing, Morpheus is for cybersecurity, Jarvis is for natural language processing, Merlin is for recommended systems, Maxine is for real-time video conferencing, so things like real-time super resolution, real-time translation. Clara is for healthcare. What else? Metropolis is for IBA, Triangle is for 5G, ISAC for robotics, and Drive for autonomous vehicle. I think I got them all right. But we have much more than this. And really what we're trying to do is be at every step, everywhere, whether you program in the cloud, whether you program on premises with a GPU, and help you build your end-to-end AI solution. We have pre-trained models, we have frameworks, pre-trained models, we optimize for the most popular data science frameworks, but also we also have transfer learning toolkits and real-time engines for some of the most challenging AI applications in the world. But not only, we haven't given up on graphics and on simulation, so we still are doing very, very large research in graphics and in AI. We have a very large research team that does research around things like GANs, does research around things like machine learning models, and even new ways to do real-time rendering and simulation. So all this is called a computing platform. We're not just a hardware company, we're not just a software company, we are a full platform company with over 1 billion CUDA GPUs in the marketplace out there, but also over 2,000 accelerated GPU applications and 27 million downloads total of CUDA. So that's 27 million, almost 27 million people who have downloaded CUDA to start using it. So I mentioned 150 SDKs, but we also have a lot of startups and communities like data science, like data scientist network in our ecosystem. And that brings us to not 2.5 million, but 3 million active developers using NVIDIA. And really building tools and solutions that are powering the connected world of tomorrow. So now let's dig a little bit into what we're doing in data science. There's been a lot of data science challenges today, really around time. Data science is super time consuming, it costs a lot of money, and it's super frustrating. But no matter where you are sitting in the pipeline, the process is super long and only is asking to be simplified and accelerated. Python tools have really democratized data science, and libraries like NumPy, scikit-learn, pandas have changed the way we think about accessibility and simplicity in data science and machine learning. While PyData is really good for experimentation, the tool lacks the power, lacks the necessary power for a lot of the enterprise workloads that you see today. That leads to substantial refactoring, handling the size of the problems, but also increasing the cycle time, the overhead, and the time to resize. So this pain point are also furthered by CPU bottlenecks. If you're doing data science using CPU and you're doing data science using a GPU, it's a much different process and a much more lengthy process too. So a couple of years ago, we launched what we call NVIDIA Rapids. So NVIDIA Rapids is a whole open source software library that gives you the freedom to execute end-to-end data science and analytics pipeline entirely on a GPU. So Rapids is but for low-level compute optimization, but also exposes GPU parallelism and high bandwidth memory through like user-friendly interfaces like Python or PyData. Add to this task, and Rapid can scale out through multi-node, multi-GPU cluster, but also accelerate data processes. And this leads to solving some of the most challenging data science bottlenecks. So much faster end-to-end performance, but also reducing the whole pipeline from a couple of hours to a couple of minutes training and deploying your model. So that gives you less time waiting, more problem solving, and more time solving harder problems. Rapids is being supported by a wide range of ecosystem partners, including some who are actively using and actively contributing to it, such as Kupai, for example, or Chainer, which is a framework done by Preferred Networks in Japan, but also as NVIDIA, we active contributors of Rapids. On top of that, it supports a lot of open source software, such as Dask, Kupai, Apache Arrow, and Blazing C4. You can use and deploy Rapids everywhere. You don't actually have to have a hardware for this. You can deploy it in every environment, including in a cloud instance, AWS or Google Cloud, for example, or even Azure. It's a really easy way to get started with Rapid. It's pretty easy, as easy as downloading the software online. And we have API documentations and get started guide that will get you through your programming process and deployment from end to end. Now I'm going to talk a little bit more about the visual computing market, which has seen over the years a lot of growth and has been fueled by emerging technologies. So for example, studios, firms, and enterprises are spending 6.5 billion hours per year to do rendering, to render high quality content, because the demand for high quality content from consumers has massively increased. They have things like Netflix, which require constant content feeding. So there is always need for new videos, new high quality content to land on all our screens. So that has increased. We have seen 30,000 new products being launched just last year that as a result need a streamlined product design and manufacturing workflows. In the US, 60% of large US architecture firms and 25% of mid-sized firms are utilizing VR today. That's 60% of AEC firms overall. Employees today, now that we are still kind of in the middle of COVID, are more likely to work remotely. So at least for part of their time. It's now close to 50%, 48%, but pre-pandemic it was much lower than this. The global in the manufacturing space, the global construction investments are expecting to rise to $12 trillion this year. And so there's a large boom in development of buildings, design of buildings, which require also high performance processing for visual computing. And then last but not least, designers are now integrating simulation tools as part of their complete design workflow. And that's, we're expecting for this 115% increase around the global simulation software markets by this year. So that means there is a huge opportunity ahead of us, professionals, but also we will need accelerating visual computing solutions now more than ever. So we are entering a new area of visual computing. And this new area of visual computing brings together a wide range of technologies, including AI, including advanced visualization, including interactive simulation, interactive engineering simulation, but also remote collaboration. All these technologies are part of the professional workflow. And now you don't only need the software and those technologies, you also need them to run on any hardware, whether you are on a laptop, whether you are on a desktop, whether you are on a data center, whether you are in the cloud. You want them to run everywhere, and you expect them to run the same everywhere. So now we want the same experience across all our systems, but we have some challenges on delivering innovation. When all these technologies are coming into play, getting professional the right power and the right performance they need to process all this is something that's super challenging. we're trying to accelerate the time to market and compress the designs, but that puts a strain on infrastructure. The enterprises want to reduce costs. There is an increased need for mobility now that people are working remotely, but also there is an increased need for data security, because if you are working with a team that's spread across Nigeria, and you're working with sensitive data, you need to ensure that these data are being kept in a secure way. 2 years ago, we launched what we call the EGX platform, which is an end-to-end platform that delivers accelerated computing in enterprise data center, and that runs most of today's applications. It's built on NVIDIA GPUs. It's a whole platform, a whole design, but also around some of the more well-known OEMs hardware, such as data science workstations done by Dell and HP, but also includes a wide range of software toolkits, including Rapids, that allow you to do professional visualization at large. We are hoping that with this, we can, by combining this with a wide range of OS SDKs and a wide range of third-party ISV solutions, we are able to provide a platform that can power multiple workloads like AI, like edge inferencing, data analytics, visualization, and remote collaboration. So that gives you a platform that touches on multiple visual computing workloads from the data center all the way to your laptop, either on bare metal or even virtualized. So engineering simulation is a big use case, remote collaboration, and I'm going to touch on Omniverse a little bit later. Remote PCs, when you combine this with some of the more traditional NVIDIA GPUs, you would get to be able to deploy in virtual workstations. So vGPUs is another use case of VGX. Data science, such as data science workstations, rendering, AR, VR, especially in 5G applications, but also scalable visualization. And it powers a wide range of applications today. So AEC, for example, architects who work with graphic and compute-intensive models and software applications. In education, universities and educational institutions who are using digital lectures and a lot of interactive digital content. In the energy space, which is highly relevant here for the market, oil and gas companies who need to run, for example, virtualized environments so that their engineers can work remotely from the pipelines. In the public sector, things like digital mapping. I'm going to show an example of a digital mapping where you need to work with very large data sets and need your data to be secured and managed in a data center. Things like healthcare, so doctors providing patients consultation and need to view high quality of medical imaging everywhere. Product designers in the manufacturing space as well, who works with complex CAD workflows and require accelerated graphics visualization and compute for running simulation. And then lastly, we touched on the data and entertainment space, where you need accelerated content rendering to drive the production of faster film and episodic TV content, so series. So that platform powers a lot of different workloads. Too much time on this slide. And now I'm going to move to something that's a little bit more exciting, the use cases. The first use case is from the public sector. So we used the 2010 census data, US population census data, and we looked at how we could extract more insights from this with Rapids. working across 5
Senegal, Rwanda, Ghana, and Senegal, Rwanda, Ghana, and Sierra Leone and Kenya, to use some of the population census that have been accumulated over the past 2 years, because for the first time in a lot of these countries, the census were digitized. So we are working with their national statistical offices to come up with the same solutions. And one of the things we're going to do is going to be launching a hackathon. So a hackathon that you will be able to join, a remote hackathon where we will provide part of this population census data and some satellite imagery data and some power and electricity data. And we'll challenge developers to come up with more insights for these 5 countries around their population. Other use case for rapids and visual computing here. This is more of a retail and demand forecasting use case. That company N-Twit used AI to accelerate warehouse shipment accuracy. They incorporated things like demand drivers, price elasticities, promotional fits, and they are providing their audience the difference between demand forecasting and demand sensing. So they are using historical data. They're basing everything on historical data to be able to predict what are going to be, what will be the forecast for demand in the years to come. Another one is around healthcare. Rapid is used a lot in healthcare and most likely in genetics. This specific example is around genomics and clinical data, and it's done by a Chinese company. They've used Rapid to speed up BGI analysis, and they have been using it to transform healthcare locally in China. So processing a very, very large amount of data, 1 terabyte, and using this to classify some tangible PET for personalized immunotherapy for cancer patients. I mentioned DAS, but financial services and fintech is also a large segment for accelerated data science for us. And fintech is highly relevant in Nigeria, but this specific example comes from Capital One, where they've been in chasing a mission to modernize their data science and their quantitative analyst and data analyst platforms. So they've started to use Rapids. They're also actually actively contributing to Rapids, and they are building a new cloud-based platform powered by Rapids that can drive widespread adoption and get great feedback around things like fraud detection. That's another healthcare example that drives better clinical outcomes. So this company, Geisinger, this research institute, Geisinger, has over the past 20 years amassed a large amount of data and patients record. They have records for over 2 million patients. And they've been using multimodal data sets alongside with some of the NVIDIA GPUs to build the foundation of their AI projects to improve at the end patient care. Another healthcare example is around digital health management. So this company, iCarbonX, has used data, a wide range of data sources like digital physiology, genomics, metabolism, metagenomics data to study the microbiome. So they're using Rapids to build those data sets and extract insights around microbiomes. This example is made by NASA. It's about global air quality forecasting, so clearing the air. NASA data scientists have been using Rapids to accelerate pollution forecasts, which is a big topic right now when we think about things like climate change, for example. But data visualization wouldn't be what it is if if it's not for the metaverse. Can anyone tell me what the metaverse is? Yes?
Metaverse is actually an online reality. Like the game was not actually physical event. Real time or life. And it's like buying lands, owning something in a digital world.
Yeah, it's, go ahead. Yeah. Yeah. Anyone else wants to take a stab and add on to that? We had Metaverse is a virtual replica or of the environment where you can use to buy lands and such. Anyone else wants to add anything? Yeah.
The Metaverse is like different reality, virtual reality, where we can also interact. That's why the world Web3 also.
Yeah.
Where we can also interact and do things and own things also, and the good as a future. But this is when individual owners can actually own things. Aside from enterprises which control the present reality now, I just like to Metaverse, we have the ability to also own it and sell it by ourselves as individuals.
Yeah.
And it's like democracy where everyone has control about what to own and also we can also put it up for sale, buy things and create our own universe. And so we have augmented reality, where it's like bringing the foreign reality to our present world, and virtual reality is creating a different reality entirely.
Yeah.
Yeah,
it's a different reality. It's a different world. But the way to describe the metaverse is a 3D evolution of the internet. So internet today is 2D. I go on my laptop, I open a Google Chrome page, and then I search on the internet, but it's a 2D interaction that's happening. Now we have a 3D overlay of the internet, which means, yes? Sorry? You can't hear? The mic is not working here. Oh, it's working now. It's working now. All right. So we had a few answers on what is the metaverse, and if you haven't heard, we had suggestion around the fact that the metaverse was another reality in which we could buy lands and we could interact with other people. The way to summarize the metaverse is that it's a 3D overlay of the internet. If you look at the internet today, the internet is 2D. That's what we call Web 2. I open a browsing page and I go on internet, but it's a two-dimensional interaction, right? The metaverse is a 3D evolution of the internet, 3D overlay and evolution of the internet, which is why we're calling it Web3. Yeah. Yes, we're calling it Web3. Like, people have different ways for it. Metaverse, Web3, or digital twin sometimes, which is one of the main applications of the metaverse. But the common point is that everything revolves around 3D interaction. Yeah. So when Facebook announced last year that they were rebranding themselves as Meta and going all in on Metaverse, it was not surprising for us because we've actually been building the tools for the Metaverse for a long time. We started to work on what we call NVIDIA Omniverse for a very, very long time. And this is a convergence of everything that's coming, everything around data science, AI, AR, VR, accelerated computing, coming all the way together to create what now we're going to call the metaverse. It's not a new term, because in 1990 there is an author called Neil Stephenson who wrote this book called Snow Crash, and that's the first time the term metaverse was being used. And he was describing the metaverse as being a collection of 3D shared spaces and virtually extended physical spaces. Basically, an extension of the internet in 3D. But today, we have massive but highly disconnected amounts of data. So there's two twin worlds. There is the digital world and there's the physical world. And today, these are still kind of separate. So when you look at things like content creation, gaming, virtual training environments for AI, factories, we're using Omniverse to connect all these and be able to build that 3D world that we call the metaverse. And for us, the metaverse is a combination of a lot of things that already exist. Digital twins, robotics, AR, VR, mixed reality, gaming, all this is going to exist in that 3D world, and all this will congregate to create that new reality that's going to be Web3 and the metaverse. So at some point, we're expecting that everything that all the interactions we're having here in the physical world will also be able to be replicated in the digital world. So think about building a digital twin of this space, this AI center of excellence we're all in today, build a absolutely exact replica of this building in the metaverse, and having all our avatars, instead of us being interacting today and me traveling to Lagos and being with you physically today, my avatar will be giving this masterclass in the metaverse with your avatars looking at it and interacting in that 3D space like we interact in the physical world today. So what is NVIDIA Omniverse, which becomes interesting when we think when we start thinking that we want to give everyone tools to build the metaverse, right? It's really a platform that connects existing workflows using familiar software applications that we already have in the world, and that are powering things like AI, physics, and rendering. So on the left here, you have collaborators that are working on different software and tools. They all compose their part of the scene. So for example, modeling props, building the environment, texturing, painting, lighting, and they're adding animation and effects. They're all connected into Omniverse, the little bubble in the middle, via the Omniverse connector. So all of us building different, owning different space of the workflow, we all connected into this Omniverse through this Omniverse connector, which creates a live platform. So for example, if I'm doing modeling props and you're doing animation and you're doing lighting and you're doing painting and we're all doing this at the same time, that Omniverse connector actually creates that live platforms that makes it alive. It's powered by what we call Omniverse Nucleus, which is really a database and a collaboration engine, which enables interchange of 3D assets and scene descriptions. Below, you have the foundational technology on which Omniverse is built. So nothing is new here, because it's the platform has been built from the ground, but it has been integrated with some of the core technology NVIDIA has been building for the past 30 years. Technology to simulate materials, physics, AI, real-time ray tracing, and path tracing. So the scenes that are built in Omniverse obey the exact same laws of physics and are true to reality. Then on the right, what you see is that the users can portal in and out of Omniverse with workstations. So I have a laptop, I have an iPad, I can get into that said metaverse. They can teleport in any part of the environment with VR, or they can mix it with AR, and anyone can view the scene by streaming on their device. The platform is based on USD, which is the Universal Scene Description, which was originally created by Pixar, the animation company, because they were trying to unify their production pipeline and assets across different software and tools internally, because they had massive production teams to design all these animation movies they were doing. And although it started in media and entertainment, now USD is being adopted by other industries like architecture, design, manufacturing, and robotics. So it makes it really easy and enable the metaverse to be built from many different actors, because they're all using a very similar, well, the exact same file format. We really built Omniverse to enable our partners and our customers and our developers to work to connect some of their most important projects. So if I can give you an example of a useful application of the metaverse that's powered by Omniverse. Let's say we are looking into autonomous vehicle and self-driving cars. When if Tesla builds a self-driving cars, there has been stories of accidents in the US with self-driving cars testing around San Francisco. Today, with the metaverse and with things like Omniverse, what this allows is that if I'm building a self-driving car and I want to understand how the car is going to interact in a certain environment, I can just replicate a 3D model, a digital twin of that environment, and have my car navigate in that environment. Take, for example, Lagos. Traffic in Lagos is horrendous. It's very messy to drive into Lagos. It's very messy, it's very dangerous. You never know what's going to happen. There's always something on the streets, right? I wouldn't let a self-driving car just like this without not being fully certified or tested to drive in Lagos streets. However, what I can do is replicate a 3D, a digital twin of Lagos, and have my digital my digital self-driving car drive and test the streets in a metaverse. For me, that's a professional use and one of the safest use of the metaverse. Another example is robotics. You know, a lot of people think that tomorrow we're gonna have robots everywhere in the next couple of years, which is going to be true, but we're still far from it because we need robots to learn how to interact better with humans. What if I want to teach a robot how to interact with a baby? Would I do it in a physical world and take the risk of putting a robot with a baby? Nah, it's dangerous, right? So why don't I build a digital twin of a room and have a digital baby in that digital twin, in that metaverse, and teach the robot how to interact with the baby in that environment, so that the robots learn how to behave. My model becomes more accurate, and when the robot is in a real life situation in the physical world, I know that what I've built has been tested and certified. So we hear a lot of fluff around the metaverse. We hear a lot around crypto, around land, around blockchain, but it's all these technologies coming together. And for me, metaverse is going to be more of a tools which will enable us to build a safer technology-powered world than it is today. Another example I could use is around climate change. One of the big words and the big things we hear a lot about today are around digital twins. Climate change is hitting us really hard, and Africa is forecasted to be the region the hardest hit by climate change in the upcoming years. There is very large, but disparate amount of data for climate change. You have data coming from satellite imagery, you have data coming from soil, agriculture, farmers, you have data that the government has, you have data that are visual data. So taking all this data, putting them together, creating those data sets and using machine learning to extract more insights is good, but it's not enough. What if I manage to extract more insights, understand how, for example, flooding has impacted some regions of Nigeria in the past, so that then I can predict what's going to happen in the next couple of years? What if when I predict, thanks to tools like Omniverse and visualization, I can actually see a real-time 3D rendering of what climate change or how climate change is going to impact Nigeria over the next 10 years. These, for me, are the useful applications of the metaverse, not the ones we're hearing everywhere online or on Twitter or on TV, which personally, I don't spend enough time in building avatars for myself or interacting on Facebook with people that I think I will just stay at home, have a VR headset and give all my classes from home and not interact with people anymore. For me, that's too far away. Probably not all generation, probably the next generation, but still it's gonna take time. But in the meantime, we can really use the metaverse for some good things. And these applications are example of it. I'm gonna show you a, so before I do that, I'm gonna look at this nice slide first. So for everyone who wants to learn about the metaverse and learn about how to use tools like Omniverse and build applications, use your AI data science skills and build this type of applications, we're actually launching a new course. So NVIDIA through DSN has what we call the Deep Learning Institute. So we're providing DSN developers access to some of these courses. And it's a set of courses that range from accelerated computing, HPC, robotics, but we're now launching a Getting Started with USD and 3D Collaborative Workflows course that you can use to learn how to put your skills and use Omniverse and build some of the parts of the metaverse. So this course is now available. You can get close to DSN agents to request if you could have some access to it, and we'll be happy to provide. I wanted to provide you two examples of digital twins before I open it for questions. Actually, useful example that are on a little YouTube video here. So we talked about digital twin. This is actually a 3D reality map, a complete digital twin of Singapore.
The project is nothing.
And you can see how it's being rendered. It's all coming from like mesh models and a wide ranges of different data. And you start with high-res pictures, and then you put them into context and pile them up with other data sources. But that what gives you is a very accurate 3D replica of Singapore. So imagine this replicating Nigeria or even the whole continent. But for us to get there, we need all of us to work together. Whether it's like technology companies who do the tools like Omniverse, whether it's the government who has like census, population census data, or whether it's other actors. Another example I wanted to show that's actually another good example is done by Bentley. Bentley is one of our partners, and they used this technology to do flood modeling. So you can predict the likeliness of flooding in certain regions. So you replicate an exact replica of the environment. You use historical data to build your data sets. Then you use machine learning to predict, and then you render everything in a digital twin, and you look at the prediction and the visualization of the prediction and what's going to happen. So in context, like I've traveled to Malawi in 2019. In remote places in Malawi, they've been hit by floodings every 4 years. So there is a lot of historical data. I worked with, are you familiar with the online hackathon platform Zindi? We worked with them to put together a challenge to predict the likeliness of flooding in southern Malawi. I'm hoping that now that we have the tools, we'll be able to also visualize all of this. So, what if you want to get started with Omniverse? I mentioned the courseway opening, but actually Omniverse is a free SDK, so you can. If you want to explore it, you can actually type nvidia.com/Omniverse, and then you have tutorials, webinars, you can download the SDK and start playing with it. The first African use case of Omniverse came from an animation studio called Arma. They're based in Ethiopia, and they did something really fun last year for the Olympics, where they replicated a 3D version of 3D AI-generated avatar first of Abebe Bikila. Are you familiar with who Abebe Bikila is? He's an Olympic marathoner, and he was the first African to win a gold medal at the Olympics, but he ran barefoot. Because the story goes that the shoes his sponsors gave him were too small, and he didn't have the time to wait for another pair, so he decided to run the marathon barefoot in the ground, and he actually went on to winning the first African gold medal at the Olympics. So it was his 89th birthday last year, and they did an exact replica of him running at the Rome Olympics marathon back in the days. So that was the first use case we had with Omniverse in Africa, and I'm hoping to see more now that we are naming animation studios, gaming studios, but also data scientists to learn how to use the platform. Because one of my personal beliefs is that technology is not going to go anywhere if it's not built by everyone. I wouldn't trust the world of technology which is only built by the US, by Europe, or by Asia. I think technology is not an end, it's a means to an end. And the first purpose of technology should be to improve the way we live and interact with each other, and make our lives better. So we do need collaboration from every part of the world, and that's why I'm doing the job I'm doing today. So I'm really, I want to thank you all for coming. If you have questions, I'm here, but thank you very much.
Thank you very much, Keith. A round of applause for me. So it's been a very, I think it's been a wow session. I don't know if there's anyone here that was actually wow with that presentation. Can I have your hands up, please? If you're truly wow, yeah. So quickly, we have a few minutes to just put this session to an end. So if we have questions, I would love for you to signify so that we can put together all the questions we have. So let's take a number 1, 2, 3, 4, 5, 6. So that'll be all before we go to the job participants. Okay, so you have just a minute, please. So would you like to have all the questions so that we can answer them together? You know, there's possibility that we'll have similarity in questions.
Sure.
So we can take all questions at this time. So
My name is Nkabwe. Thank you, Kate, for the wonderful presentation. I will appreciate your input. So I have two questions. Number one is on Metaverse. Okay, because recently, since Facebook change wants to mentor, it's need to mentor and a lot of things going on Metaverse. So I want to have a clear understanding. What is the difference between that Metaverse and, because I have an engineering background and I'm used to 3D simulation thing. You put input, you get output right there in 3D. So what is the major difference between that Metaverse they're talking about now and then what they've been doing since, whether you can have different 3D software that have been developed there? Second is concerning the mapping software that you said can be used for visualization. As data scientist, I'm used to importing like Matplotlib in your Python environment wherever you import it. How do you use this mapping? Is that it's different software entirely, or you import it into your environment just like you do for Matplotlib and other software? Thank you.
I think it's easier to answer one by one. Okay. I'm gonna forget questions otherwise. Thank you for your question. I'm gonna start with the Rapids one, and then I'll go to the Metaverse one. So Rapids actually is trying to simplify and gather all the tools that you are already using. The interface is Python and PyData. So everything that you've learned as a data scientist using Python is also valid for Rapids. The only thing is, under the hood of Rapids, things that you don't see is that there are a lot of libraries that are accelerated and simplifying the data science workflow. So this is what we've tried to accomplish with Rapids, and then you get from having to use 5 different tool suites to just build your whole data, to go through your whole data processing pipeline to having to use just one. And Rapids is constantly being updated and constantly being growing this ecosystem of partners. So MATLAB, Blazing SQL, they're all part of this ecosystem. Now, going back to your Metaverse question around how to solve through the cloud, I actually also went through the exact same thing, because I've heard of crypto and blockchain for so long, and then the Metaverse comes in, and I'm like, oh wow, but wasn't it what we were building with Omniverse? What's the difference between all this? My advice to you would be, as a technologist, go back to the technology. Right now, there's a lot of fluff around what the Metaverse and Facebook can do, but in reality, they're not reinventing the world. They're just looking at existing technologies that are coming together. So AI, data science, 3D visualization, blockchain. Blockchain is an exciting one to look into, not the blockchain for crypto, but the blockchain for smart contracts, transparency. One of the things I'm exploring right now is decentralized AI. What can we do? Can blockchain enable decentralized AI? So for example, we all decide to get together as a decentralized autonomous organization, the DAO, something that you hear a lot lately on the news when it comes to Metaverse. And we decide to build an AI model or a suite of AI model, and each of us are contributing. Imagine that you could track how and when your AI model has been used throughout the years. And then all of a sudden, we all start to get, let's say maybe like even money from people using our model and not licensing our model, but using it online. But we have that transparency to be able to track everything back years, because everything is written in the blockchain. So my advice to you would be start with the technology and really try to look under the hood. The way I learned was online. There are a few blog posts, newsletters that you can follow, but Omniverse is also a good way to start, because it's using all the technologies that you know. And as you understand the tools that are being used to build the Metaverse, you will understand what the Metaverse ultimately is, and you'll be able to solve through the fiction and the aspirations of the likes of Facebook, and then the reality of the technology.
Right. Okay. Thank you for the class. Okay, what?
Okay.
So you mean having for example, we're building a simulation for a self-driving car. Would it be just us having, for us here, like a simulation of this building, for example? Would it be just us having access to this building, or would it be everybody being able to see it and contribute and, right?
It can be like a physical, it can be physical, it's a really physical environment, and the humans be the only things that are virtual. Is that how like NVIDIA plans on doing that for self-driving cars?
So the example I used for self-driving car is a professional example. So now you are making a parallel with the metaverse that's consumer, that's the one Facebook is trying to build. If I had to summarize what Facebook is trying to do, it's basically replicate Facebook, but in 3D. That's exactly what they're trying to do. And that's what they call their metaverse. So that's why they say, oh, we all interact with each other. Now, the things we're building with Omniverse as NVIDIA are, our first audience are professionals. So let's say architects who want to build a simulation of a building, Bentley, who wants to build float modeling, Mercedes or BMW, who are working on the next generation of self-driving cars. So it's not a B2C example, it's not a consumer-aimed product, it's actually a B2B and then B2B2C. So it's a little slightly different approach to Facebook, but it's building the foundational tools that Facebook at some point will probably have to use if they want to build a 3D reality, that 3D version of Facebook that they're building. So to answer your question, looking at us building a 3D version of anything, any company can do it today with Omniverse. But if us get together and decide to build a 3D simulation or a metaverse equivalent of Legos, we can all contribute to that. If we launch a project online and say, hey, I would love to build a 3D version of Legos or a metaverse version of Legos, who wants to help? Anyone can contribute, but you will need a lot of different data sources. A lot. A lot, whether it's from businesses, whether it's from the government, the national statistical offices, whether it's from some people at the UN there is this platform that does open data, I think called HGX, and has a lot of it's an open data platform where you get data of like demographics and everything. So that could be a good place to start, but it's going to take a while.
My name is Benjamin Adekunle, and I really love your presentation. It was a wonderful presentation. Thank you very much. My question goes as follows. You talked about how you can create virtual environments to train ML and artificial intelligence instead of actually training them in real time. One of the things have you ever heard about the AWS depressor?
Yeah.
Now, one of the things I discovered, and one of the things I was actually you first train your model on the web, like online, before actually bringing the model, downloading it into your machine and trying to present it. One of the major problems is actually trying to simulate that same environment and trying to get it accurately on real world. Because when you are training something on the internet or on an artificial environment, the way to perform will be different from when it's actually in real world. So how do you adjust your algorithm and your models to actually account for difference in this environment? And my second question goes, we are always talking about tools of how to use data visualization, but how do you interpret them properly? Because it's somehow very easy for you to just view one thing and just look at it and think you understand it. But it may actually be more than actually what you actually think it's saying. So how do we visualize and interpret visual data visualization, whether about population centers like you showed us, or just simple linear regressions? So that's my question. Thank you.
Thank you for your question. So the first question around model simulation, model deployment, and the model performing differently when you actually train, deploy on the web, and then deploy in the real world. There's something we've built at NVIDIA, which is called the Transfer Learning Toolkit. For me, the answer to this challenge is actually having some sort of reinforcement learning that you can do where your model can be slightly retrained, adjusted for the real world conditions. So you should definitely check out NVIDIA Tau, which is a transfer learning toolkit, where you can actually, you don't have to completely retrain your model. You can just adjust a few parameters for it to perform well in the real world. Now, moving to the second question, which was around interpretation of data. How do we interpret the data that we can visualize in a better way? I think one of the things that has changed the game for data interpretation in the past couple of years is actually machine learning. So before, I'm going to take, for example, the census data example. Before, when governments were doing census, they were doing census and then building a couple of charts with, hi, that's how the population has evolved, that's how many more babies we have, that's how many more schools we have, that's how many more buildings we have. But now, what they haven't realized, but what us technologists have realized is that put all this data together, build a machine learning model, and start doing prediction. And for me, prediction is the way that we can extract more insights from this data and always discover new way to interpret and use this data in a visualization context. So machine learning and prediction for me are the answer to this.
Thank you for the presentation. Very nice. My question is we have AI, artificial intelligence, we have machine learning and deep learning. My question is the deep learning, my Metaverse cannot be in existence without the later collection of deep learning and all this. What is the major connection with all this AI, machine learning, deep learning, Metaverse, and all of this? Where does it leave Africa? We have majorly, that's the second question, consumer society. We don't have, and another thing what all this require is heavy data, accuracy of data, and data management. We lack that culture in this part of the world. Now, how do we have to relate to the world in that environment?
So the first question around the correlation between AI, machine learning, and deep learning, and then the metaverse starts with deep learning being a subset of machine learning and machine learning being a subset of AI, but it's all the same technology for the three. It's just different ways to get to this a similar outcome. Now, if I put this in perspective to the metaverse, the metaverse is not a technology. So AI, machine learning, deep learning are technology. The metaverse is not a technology. The metaverse is a solution built with technology. And some of the technologies that are being used to build the metaverse are actually AI, machine learning, and deep learning. So you could connect, like I mentioned, what Omniverse is doing is using 3D visualization workflow coupled with AI, AR, VR, and then you can create the metaverse. So it's a subset of tools. AI would be your tools to help create the metaverse, but the metaverse is not a technology. It's just a rendering, yet another rendering of technology, like building a graph, for example. There was a second question?
Africa, and majorly, all of these rely heavily on data. Data management is done in our culture here, and more also accuracy of data.
So the good thing with data is that data is everywhere. Data has no border. So we have as many data here that we have as in the US. The only difference is that they have much more devices to collect and process them than we have here. One of the things we need to figure out, and the things I've been encouraging wherever I'm going, whether it's talking to the private sector, to the public sector, to the UN, to developers, to startup, is that we need to start collaborating. If not sharing this data, figuring out a way that we can collectively build something that's going to be useful for all continents. So based on this, I think even us individually, we all have a role to play in that, because some of you are data scientists, some of you are machine learning engineers, some of you are data engineers, some of you will build devices, you're hardware engineers. What if we work together and create a solution? It doesn't have to be very big, it can start small, but coupling all this and creating that whole workflow, it gives us an opportunity to build the solutions that will solve challenges for us here in Africa, rather than having to take technology from somewhere else and import it here. So for me, the key for that is that data can be localized. You have data everywhere, you have data here, so the solutions you're gonna build using the data, the localized data here in Africa are going to be different there. If there is a need to increase data collection at the edge, at the endpoint, for example, deploy sensors and so on, there are some entities who can support. I'm the chair of the Tiny Machine Learning for Good committee, and TinyML was a conglomerate of tech companies like Facebook was in there, Google, Samsung, ARM, that came together to look at machine learning on microcontrollers, so very low power, low resource devices and sensors. So now you can actually do machine learning. When you collect data with sensors, there are some that can process some very, very small part of machine learning. I know that the community, because I chair the committee, I know the community also provides hardware grants. So if you have a project, that's something you can request, and you need sensors to collect some of your data, that's something you can request. We've been working with a lot of chapters across, there's one in Nigeria, there's one in Kenya. The one in Kenya, in Nyeri, at the north of Kenya, has deployed a machine to monitor one of the Kenyan rivers, and then they've been building, and now their device has been deployed all over Kenya by the government for wildlife conservation.
Well, first, I wanted to say thank you for the presentation. It was very good. My question was around one of the use cases we saw about how modeling like a city in Singapore for traffic. So I wanted to ask, because for something like that, we already have like say Google Maps, how you can do like a satellite view, and if you zoom in, you see like you see the city, like a 360 view. Let's ask in terms of practicality, because a lot of these things already have. So something like this specific case, how is it any different from the technology we already have?
That's a very good question. So Google Maps, which is satellite imagery, everything that's already existing, is one of the options for rendering based on data. That's based on satellite imagery, visual data, and that's how you render it on Google Maps. Now, if you put to parallel building a digital twin of Singapore, which is much different because it doesn't just relies on one source of data. So Google Maps could be used as some of the data inputs that we're going to use to build the digital twin of Singapore. But not only, you will need information from the building itself. You will need information on traffic management. These are information that Google Maps doesn't exactly provide you. You will need information you need all the sources of data. And then you will need to start coupling and modeling all this data to render that 3D twin of Singapore. So the answer to that question is that Google Maps could be one of the data source that will be used to render that digital twin. What you can do with that digital twin is simulate your environment real time, which you can't do with Google Maps because Google Maps is historical data. The way Google Maps collects data on Lagos or in Singapore, they used to have those like Google trucks, and they used to have those little antennas and pictures and cameras all over the truck, plus with satellite imagery and running the trucks across the city and across the country. Now you're actually able to do this without having to run trucks everywhere because you have already those data sources that are existing. It's just coupling all of them and creating that digital twin, which is going to be much more accurate because you don't rely on a single source of data.
Thank you very much. A round of applause for Kate. Thank you very much. So I'll quickly read some questions I will have. Okay, let's just do this. Yeah, thank you very much, Kate. Honestly, the presentation was wonderful. 2 weeks ago, I'm actually completely now on AI actually. So I'm moved by the possibilities of what AI can do. My question actually centered around the metaverse and the deep learning training. Also, I would ask down metaverse because it's actually my fourth time hearing about it. Is that basically the individual can actually be in their home, like most people will be in their home right now, and you actually access the internet. Like because you don't have like this, like it's a whole new world on its own. Everyone can be in their home, their various locations and see it. And also concerning the deep that is going on Omniverse, I want to ask, is it going to be physical or virtual? I think it's going to be physical. I want to ask, is it going to be only Nigeria?
So the deep learning training, you can do deep learning training anywhere. The one that's going to power the metaverse is highly similar to the one we're already doing today, except that training your model on your machine and coding, you actually train your model in the 3D world, and your model representation could be a 3D robot in a 3D space. So basically, it's just a rendering of your model. The example I used with the robot and the baby are rendering of what you have on your Python machine, right? They're just a representation of it in 3D. Similarly for the autonomous vehicle autonomous driving example, as I replicate a digital twin of Lagos and a digital twin of a fully autonomous Mercedes driving around Lagos, it's actually just a rendering or a representation of my machine learning model that's sitting on my machine, but it's a representation in 3D. So the environment is much more accurate. You're able to see and visualize how your model is going to interact in the real world. You get what I mean? It's a bit complicated, but and if you think, for example, what is a simple example I could use? If you think about VR headset, if you think about VR headset, so what you see in your headset is just a representation of somewhere. So let's say I have a VR headset, I see Tokyo, but it's a representation of Tokyo. What runs on the VR headset chip is a model, it's a machine learning or a graphics processing model, right? So it's just a representation of it. So the metaverse is going to be the exact same thing. I'm going to build a model for an autonomous car, but I want to know if that model is going to be able to interact with the environment in Lagos, and I want to see it. So for me to visualize it, it's going to be like putting a VR headset and all of a sudden being in that that environment and seeing how my model, instead of like seeing ones and zeros of code, I'm gonna be able to see like visual representation of my model. It's like your model, your deep learning model coming to life. That's pretty. I like Yeah, you can simulate and be a human. You can generate an avatar. You can have computer vision algorithms that will be figuring out post estimation, post detection algorithms that can figure out what you're going to do if you're a person in the metaverse. Everything that you can build with a machine learning model today will be able to be visually represented in that 3D world.
So thank you very much, Kate. I think quickly, because you are way behind time. So I'll just read out some questions. There's a question from Yakubu. How do we go on Metaverse using internet? What's the link to the course on learning more about it? As you mentioned, that's the first question. Don't know if I can take another one because of time. So thank you for the presentation. How can we have access to these graphic chips, different types from the market? Being fully well that there are different types of laptops in the market. So Jack is asking that. Okay, everybody said, how can one transition from another industry into data science? I don't know, do you want to take the three now?
I can take the three. So the first one was how do I start with the metaverse and how do I access the metaverse? There are a few applications. Again, there is not one of the preconceived ideas is that there is one metaverse. That's not true. There's not one metaverse. There are many metaverses that people are building. Like you can build a metaverse, I can build my own, you can build your own. So there are many metaverses out there. And there are many applications where, so for example, you hear a lot about people buying lands in the metaverse. The application that allows you to do that is Sandbox. Then you hear people transacting in the metaverse. The applications being enabling you to do this or the crypto wallets. So it's a lot of different technologies that are coming together. So depending on the purpose he's trying to achieve, he's gonna have to go to one of these software. Now there is the second question was the chips. Oh, accessing NVIDIA chips. Well, if you're a part of the data scientist network, you can help access them here. So part of the emerging chapters program that DSN is part of at NVIDIA is also providing hardware that developers like you can access. So building supporting small center of excellences across the continent to increase hardware access. That's one of my personal goals to reducing the compute divide. So you can come here and access it. We can also look into providing codes for cloud instances. So no physical hardware, but being able to access a GPU instance through AWS or Azure or Google that will give you the exact performance of the GPU, but through a cloud machine. From Web 2 to Web 3. Industry to data science. How can someone transition from another industry to data science? I think here is also the perfect answer. You can come and start learning through DSN, right? You have the opportunity that this community, which is probably one of the best on the continent, provides you with everything you need to get started as a data scientist and help you throughout your journey from just the concepts to actually work and building applications. One of the things we see as technologists is that a lot of people coming into work into AI and data science have studied at university, but have never actually tried to build solutions. And this type of structure is providing you the opportunity to work on real world solutions, which I think is a great skill for finding a job in data science.
Thank you very much, Kate. I think other questions are somewhat related. I'll just put them together so that we can round off here. So I think there's a question here clearly on Bismarck. How does Metaverse react to decentralization and the economy at large? And how is intellectual property in the Metaverse controlled? Then there's another one very closely related to that. What are the basic tool requirements for creating a unique section of the Metaverse? Say creating like an office, like I'm in right now. Then the final one is asking questions on Metaverse to something very related stuff. So I think they are just wild about the Metaverse. So I don't know if you could probably do like a summarized this thing to just do that.
101 Metaverse crash course that I was not ready to give today, but so we talked about representation, we talked about how it's a combination of different technologies being visualized in 3D. Now comes the question of decentralized, centralized, economy, not economy, finance, not finance, all these new terms coming into the picture that we hear everywhere, DeFi, ReFi. It's very confusing. I can give it to you. One of the way I will summarize this with using some buzzwords that are being used right now, but then simplifying them. The whole first purpose of crypto, blockchain, and now the metaverse, but going back to the fundamentals and the technology, right? Looking at blockchain. Blockchain is a technology that was built to allow transparency and accountability, and also traceability of everything. Blockchain is fully transparent. It means that if you and I are making a transaction, it's going to be written in the blockchain forever. Now transpose that into the real world, and let's take an African example. If I'm buying a land in the outskirts of Lagos, for a long time, it happened to my mom actually in the car. For a long time, when I was going to buy a land to a landowner far from the city, he was selling me the land. If I was living, coming back 2 years later, that land had been sold to somebody else. And then the only thing I had to prove was a paper, but no one believed me. And the other person had already started to build on that land. So what's left of me? Nothing. That happened to my mom. Imagine if I go and buy this land, the transaction is written in the blockchain. I leave and come back 2 years ago, and I have all of a sudden a way to prove that that land originally belonged to me. But more than anything, that land cannot be sold to somebody else, because what that person is going to look at is, okay, give me the reference of that land. I open a blockchain because there's already a smart contract. I'm not going to buy that land because it already belongs to somebody else, right? So I know the owner is lying to me. Fundamentals of blockchain, that's accountability, transparency. It's highly relevant in our continent where we still a lot of corruption. If I give you an example for charities, there are $250 million giving to orphanages every year. Orphanages conditions are not changing. Whether it's here, whether it's in Southeast Asia, it's all the same. If I give a $1,000 check to UNICEF today and say, oh, it's for orphans, what is going to happen to this $1,000? UNICEF is going to take 35% operations cost. It leaves us $750. Those $750 sent to the government of Nigeria. What do you think government is going to do? Right. Put in their pockets, right? Half of it. Let's say I'm left with $350. $350, the minister gives it to the person who is supposed to drive to the orphanages to distribute the money. What is that person going to do? Right. Take another 200. Then I give 150 to the director of the orphanage. What the director of the orphanage is going to do? Yep. So what's left for the orphans? Close to nothing, right? But then, how do I know who took what in those $1,000? So imagine now, I give $1,000 to UNICEF and I write a smart contract. Every time UNICEF gives the money to somebody, the transaction is written in the blockchain. I know what that person received, what was left to UNICEF, and where this money is going. And when it gets to like the director of the orphanage, let's say he's left with much more money now, 900, 800, because everybody's scared, because not everybody can see who took what of the money, right? So no one is touching the money anymore. The director of the orphanage gets $800, and then I put a smart contract and I say, you cannot cash out that money. The only way you can use that money is to spend for infrastructure, like to selected vendors, or to spend to buy food, or to spend to buy this for the opens, and we're gonna check the bills. Because we can, because it's transparent. So that's what blockchain is allowing you. Transparency, accountability. That's for one part of the metaverse and crypto and everything that's coming up. The second part, going to decentralized and centralized, there is one thing we hear a lot about today is DAOs, decentralized autonomous organizations. DAOs are a new, I would describe DAOs as mini democracies. All of us get together and decide to create a DAO. Let's say we all care about orphans and we want to create a DAO that supports orphans. So we all get together, we all buy tokens. We actually create a token, we create a currency for all of us here in this room, one currency, all the orphans with a dollar on it, like we see everywhere, like the orphan coin. We create the orphan coin, we all start putting money. I put 1,000 naira, you put 1,000 naira, you put 2,000. We start putting money towards this coin, right? We start minting our tokens. And all of a sudden, we all have a share of what is the orphan democracy that we created at DSN today. And we can all vote. That means we all have votes called snapshots. There's technology that does that. Votes called snapshots. And all this money that's going to the orphanage, we can decide how this money is going to spend. We all have a right to vote on how this money is going to be spent. That's what we call a decentralized autonomous organization. Second concept of Metaverse. Then the third one is NFTs. We hear a lot about NFTs. What are NFTs? Non-fungible tokens, which means it's an asset that cannot be replicated and that is unique to you. So, for example, the best NFT example that I can use is the Mona Lisa painting that's sitting in the Louvre in Paris. There's only one Mona Lisa. No one can replicate it. If somebody gives it to somebody else, like, we're gonna know this thing costs millions and millions of dollars. NFT, that's what an NFT is. You can now create an asset that's unique, that has a unique value and can take on value if people really want to buy that asset. But then you can track, thanks to blockchain, going back to the first concept, you can track how is that asset has changed hands, right, over the years. I can track everyone who has been the owner of Mona Lisa over the years, right? So that's what NFTs are allowing, and that allows more money for the creators, and it allows them to control their arts a little bit better. What else is a concept of the metaverse? Well, all these combined creates the metaverse, and all of a sudden, let's say we have a digital twin of the orphanage. Orphans can now create NFTs, put it on auction on the metaverse, sell their NFTs, make money through these NFTs, right? All of a sudden you create a microeconomy, and us as DAOs, we look like, oh, this is great. Let's spend more on schools. Let's teach technology to these orphans. Let's teach them how to create NFTs. They create NFTs, they make money. We have digital twin of the orphanage. They do a whole exhibition of their NFT, like a whole gallery in the 3D version of the orphanage, and so on and so forth. So that's kind of a 5-minute summary of what the metaverse and all these features can be. I know it's confusing.
Let's appreciate it once again. Thank you very, very much. I think it's been a very well session for the team. We appreciate your time. On behalf of data scientists network, the board, the members, able participants to online and on-site, we want to say thank you for your time. We really appreciate you, and I think you can give our feedback to NVIDIA that we also love, and we're proud of how much you're supporting us. You can see what it's turning out to be. So let's give it up for Kate once again. Thank you very much. I think a colleague of mine will just take you off there so that we can come into it. See. Okay, so shortly, I think in the next few minutes we're going to be rounding up for both. Pending that time, I would like to bring up the impact network lead for the design network. The community, everything community in DSN is led by this gentleman. Please let's appreciate him. So we talk just briefly on the current project participation that we are running that relates to data visualization. So I think to a very large extent, we have an idea of what we can do with this skill that we're trying to pass across. Thanks to Kate who has taken us on the advanced level to see how these things can come out to be. So David has a few minutes to run us through where we are and what this session is talking about. David. All right, thank you so much. Hi everyone, hope you have been enjoying the session so far. That's great. Right, let me quickly walk you through the current aspect of the session. All right, David. So I'm very fully aware that the current project participation that is ongoing, a lot of you already been participating and I've been very happy from the conversation on the Google Classroom. And I want to confirm from here again, how many of you already joined the program during the ongoing project participation that we are doing with Power BI? Okay. All right, okay, I can see. All right, so now we are going to be launching the program, the data challenge today of AI and financial inclusion. So what this dashboard challenge is going to be for everybody is that going to equip you with skills, give you some scalability on how to create visualization using Power BI tools. And also, this web page that we have on this challenge being hosted, you will share with everybody via email and also my colleagues are sharing on the Zoom call. So you all are going to be having access to this. So we have the data set for the challenge already being posted here. You can have access to it here. So we already have a pack of data started from 2008 to 2020 for financial organization NVIDIA. So we have helped us with the data set that we're going to use for this challenge. And also we have the meta data which explain all the definition of terms and also the variable names that's being involved that are being used in the data that we are going to be analyzing. So we have this data being compiled here, so you can access it on our website. And also we have the full details of it that can be accessed here. And also the ongoing class is going to be third week for, I think that is quarter 3. They're going to be having their class scheduled today this evening by 5 to 6. So the challenge formation is going to be, the deadline is going to be on the 8th of April. The due date is going to be Friday, 8th of April. So these are some of the opportunities and benefits that you are going to be having during the session. So there's going to be the opportunity for you to exhibit your work, able to show your quality, your skill, and also show what you can do with building visualization. And also, it's going to be an opportunity to advance your career in DSM mentorship program. So for the people that actually participated very well, they are showing a lot of dedication to the project work. So we are going to be onboarding them into mentorship program, whereby they can have a follow-up of from the advanced people who are already industry experts. So help them scale their skill and also to be able to achieve their dream in terms of being the data analyst or BI experts. And also, the expert and peer can teach you something new. So I'm very sure that when you are working together with a pair of people who have the same common goal, when you are stuck, people teach you anything, you get to know more about what you don't know. So when you are participating in this program, be able to ask questions and also get more clarity. So improve your credentials as far as especially by doing what employers are searching for. So this data that you're going to be using for this challenge is a real life data set that is going to give you hands-on experience on how to handle industry data. So it's going to be one of the things that I'm sure you are looking forward to. So This project is going to expose you to different domains of knowledge, whereby you need to understand how to work in maybe how to take out regarding manufacturing, finance, any aspect of it. So it's going to help your career to go in a lot. That's one of the things I'm going to assure you. So another thing that this you are going to be gaining for participating in this program is that you will be able to recognize the most prevalent solution before. So what make a good dashboard? What are the things the management, the executive are looking forward to in identifying a good dashboard? What are the metrics that is really aligned? What are the things that the solutions to look for in the dashboard? So what is going to be one of the key takeaways for you and the benefit? Then participate in discussion about how to improve your solution and learn about their capability. So from this, if you participate in this challenge, your weakness is going to be your strength, so that because going to give you another installation, okay, this is where I am, this correct time, this is what I can do. So the next challenges that we are going to be working on, I'm going to go beyond this level. So it's going to give you more morale. The opportunity to be among our talent pool for the business developer job. So we have some jobs regarding checking that or anything related to that analytics. So by showcasing what you can do, this will give you opportunity to be among the people that recommend for this opportunity. And one last thing that's going to be that is going to be given to the participants is that they're going to be in space of participation of this is going to be recognized and also trackable. So participating in this challenge is one of the exciting things I'm sure you all be looking forward to. So we normally have the course class schedule on this Power BI class on Wednesday 5 to 6 and also on Friday 5 to 6. So our session is going to be going on this evening at 5 to 6 and also the opportunity to be part of the facilitator is going to be on the video by Friday as well. So I'll be looking forward to having you guys training online as well. So even the project participation description. So if you're an analyst looking using the financial sector, the financing compile the cost of financial inclusion in the sector. Let us contain information on gender, age, geographical zone, settlement, and outliers. The manager requires that you produce a report that look at the data set and give us some insights on the interpret of the variable. So the goal is not your call as an analyst and you must figure out how to communicate information and drive insights using a publishing visual. So the objective is very clear. Produce a report which summarizes the data set. So we have the data set here and the solution requirement. Just kindly ensure that you're reading the solution requirement so that you can produce high quality solution and while maintaining the beginner spirit of the challenge. So ensure that if also make your Power BI work, you come to this page, you click on this requirement here, you take it to the code to upload your Power BI work. And also, you need to follow BSN and data scientist network on LinkedIn, share, and then also share the link post that contains direct mentioning to data scientist network and then as mentioned financial inclusion challenge to your post. So what is speaking to is that when you are done with your dashboard, you have created a dashboard, take a screenshot of that dashboard, then post it on LinkedIn, just mention BSN as your post, and then we have this hashtag here. Just put it in so that you can see your post and we can give you comments on it as well. So one additional thing that you can do when you are building a dashboard is that you should be able to keep findings and all you have done. So let's have a summary of your findings, comments about your dashboard. So that's going to help your report as well. You just before you start giving a dashboard, you have your objective, what the solution you're trying to find or solve that problem. So you should be able to give a point, the summary of your findings on it. What you are, what your dashboard is actually able to solve. So that's very important. Then as well have your friend so that they can actually let your work, give a comment on it. So the due dates about the inner cell is 28th of April. And then if you have any challenges like any of the process, you can send your inquiry to project participation by data scientists Nigeria.ai. And also, I realized that some of you don't have a license to publish on Power BI. You can as well upload your work to this project participation and have them to help you publish it and share the link to it for you so that you can use it or anything. Maybe you want to add it to your resume or anything. So we can just upload it for them and give them the shortcut to every publish it. So this project, this data for this project is being supported by NVIDIA. So I will, okay, my colleagues already shared the link to the group. So to the people on site, we are going to send it to your mail as well. So you are going to have access to the link. So that you can all put in your place and build a very useful dashboard that that's insightful and also that can bring a solution to one of the problems we are facing in Nigeria in financial sector. So thank you so much. I don't know if you have any question. I mean, like to take 2 or 3 questions on this. Okay. We confirm that the lead stands are very very on me. Okay, so we have the email. This is the email that we have there. This email. So send your inquiry to this email. Yes, exactly. Example. Go ahead. No, this is not this. So this is a regular data. Yeah. So if you go to the in our web page, this is a real life data. This is a public data set. These are the data so used to produce a dashboard, a report before and see it. So this data, but these reports are being, you see, this web page where the data, where we have each of the data, they are published yearly. So what they have done here is that they put the data together, consolidated into a single Excel file. So it's just for you to create the dashboard, show the trend by year. You understand? Instead of having single reports for each year, you see the 2014, 2016. You understand? So the data has now been compiled. So you now use it to make a dashboard. All right. I'll use it to tell you a compelling story. All right. Okay, thank you. In the absence of any other questions, I have to back to the. I thank you very much, David. Please let's give it up for David. So I think it's pretty much straightforward. The dashboard project participation challenge has kicked off. So in light of that, we'd love everyone to just try and lay your hands on possibility of creating the dashboard, which we put together. And like you said, it's going to be very big. We intend to, because it's big, so it's still going to be treated as very big. You are free to post it on all your social pages, chat data scientist network, and we're putting this together. We'll get a feedback, we'll get across to you. So in order to close this session, I would be inviting our executive director. Please, I want you to appreciate Mrs. Doing everybody as you come to the thanks. Please appreciate that.
Thank you, and thank you, Kate. On behalf of Data Scientist Network Foundation, we say a very big thank you to you. Can we give her a round of applause? We do appreciate the selflessness coming down from US down to see us is really a big deal. Let's give her a round of applause again. And not only coming to see us, to impact knowledge. Wow, that is really, really amazing. A very big thank you to you. And to NVIDIA too, they've given us a lot of tools to work with. Let's celebrate. Thank you, thank you, thank you so much. We do appreciate you. And we hope that this is the beginning of our partnership. And we hope that the people here will one day give back to the society as you have done today. Once again, we say thank you. And to everyone that is here, I hope that you have learned a lot. And it's not about coming here alone, it's about impacting your generation. 1 million talent is a must. And it's not only for you to be a talent, it's for you to be able to do things that will impact the world. The world is waiting for all of us. Thank you, and have a good afternoon. Thank you. So to close this session, we'll just be having picture session with her, a memorable one that she can go with. Thank you. So we can all move to the back.